All right, this is a video for section 5.2 binomial experiments. I'm recording this because in the video 5.2, Al, I call him, uses a TI-83, and obviously most of us have the TI-84. So I wanted to record this video just to go through the three types of examples that I incorporated in this section. There are two calculator functions, but basically three types of examples. The last slide of the PowerPoint has these what's called common English expressions and corresponding equalities. In other words, when you're reading the problem, you got to take the problem and rewrite it as an inequality. So I would definitely suggest downloading this particular slide, the last slide of PowerPoint 5.2. Four or more successes. R is greater than or equal to 4. Now recall, in your calculator, it doesn't use the letter R, it uses the letter X. At least 4, no more, no fewer than 4. 4 or fewer, more than 4. These are all the inequalities that are associated with those common English phrases. Here again, I would strongly suggest downloading that last slide. All right, so how do we start out? Central problem of a binomial experiment is finding the probability of R successes, R and X are one and the same, now they're synonymous, out of n trials. All right, we'll see how to solve these. He gives us a formula, the author. All right, it's fairly complicated. It's the combination of n things taken R at a time times the probability of a success times R, how many successes you have, times Q, the probability of a failure, raised to the n minus R exponent power. Yeah, it's not a tough formula, but there's ways of getting around it a lot easier using your calculator. All right, so here's an example where privacy is a concern for many internet users. One survey showed that 59% of internet users are somewhat concerned about the confidentiality of their email. Based on this information, what's the probability that for a random sample of 10 internet users, exactly six are concerned about privacy? So we know n is 10 users. Probability of someone being concerned about their privacy, 0.59. Now, when you use the formula, you got to calculate what Q is. If P is 0.59, probability of a success, probability of a failure is 1 minus 0.59 or 0.41. R is equal to 6. R and X are synonymous. You're interested in exactly 6 being concerned. So putting those values into the formula, it's 10 things, combination of 10 things taken 6 at a time, times P to the probability of a success, 0.59 raised to the 6 times Q, which is 0.41 to the n minus R power, which is going to be 4. All right, so it's this times this. I mean, it's not a tough formula, but you see the answer comes out to be approximately 25% of folks are concerned. It's not a tough formula, but there are easier ways of doing it because you have a calculator. All right. Here's that same problem, and I'm going to do it utilizing the calculator. Here again, same problem. 59% of internet users are concerned about their privacy. We got a sample of 10 users. What's the probability of exactly 6? So if I call up my calculator, and I'm going to turn it on, and let me clear this off. First thing I want to do is check my float. And I'm going to leave it at 3 places, which is okay. All right. I'm going to quit out of this. So, whenever you're asked to do the exactlies, all right, the exactly 5, exactly, in this case 6, you're going to go to second function, hit your vars key, and come down to, on the 84, letter A, binomial PDF, probability distribution function. Whenever you're asked for exactly, this is what you're going to use. I'll press enter, and it simply asks me for 3 things. It says how many trials you have. Well, we have 10 trials, 10 users. What's the probability of someone being concerned about their their email? It's right there, 0.59, 59%. Making sure I change, 59% to 0.59. and I'm interested in exactly 6 people being concerned. Go to paste, hit enter again, and there you have it, 0.250. And when I did it with the formula, it came out to be 0.25, and obviously 0.25, one and the same. I've got my calculator set to 3 decimal places. Let me close this up. In fact, let me clear this off. Minimize that. Same type of problem. Suppose 11% of the people in the United States or whatever are left-handed, maybe at Bridgewater, who knows. 11% of people we survey are left-handed. If 8 people are selected at random, what's the probability of exactly 2? All right, so it's interested in the probability of exactly 2 out of 8. And there's 8, probability of someone being left-handed is 11%. That's 0.11. Because I'm asked for exactly 2, I'm going to be utilizing PDF. Second function, the bars, come down to letter A, binomial PDF. I can clear this off. I only have 8 trials now. Probability of someone being left-handed, 11%, that's 0.11. And I'm interested in exactly 2 of these people being left-handed. So my X value is 2. Remember, X and R are one and the same. All right, hit paste. Hit enter again. I got an answer of 0.168. Now, of course, on your homework, on an exam, if you had 2 decimal places for all your answers, you would round it up to 0.17, or you would set your calculator float to 2 places. All right, let me minimize that. And next slide here. All right, here's the deal. So we did PDF. Only time you use binomial PDF is when you're asked to find exactly 1 or exactly 2 or 4, whatever exactly. But in many cases, we'll be interested in the probability of a range of successes. For instance, a company purchases shipments of machine components and uses this acceptance sampling plan. It randomly selects and tests 14 components, and it accepts the whole batch if fewer than 3 are defective. If a particular shipment of thousands of components has a 7% defect rate, what's the probability this whole shipment will be accepted? It will be accepted if fewer than 3 of these components, machine components, are defective. Fewer than 3. Probability that X is less than 3. Well, if there's 14 components, less than 3 means 0, 1, or 2. All right, so I could, if I wanted to, and I had a lot of time, I could use PDF 3 different times, find a probability of none of them being defective, plus the probability of 1, plus the probability of 2. I'd be using the PDF 3 different times and then have to add the answers together. Don't want to do that. There's a function that bails me out. Go back to my calculator, I clear this off. I go back to second function, hit my vars key, and now I'm coming down to not binomial PDF, but binomial CDF. The C in CDF stands for cumulative. What's it going to do for me? All right, it's going to start at 0 and stop when I tell it to stop adding probabilities. All right, CDF always begins with 0 successes. All right, and it stops adding when I tell it to stop. I want to add a probability of 0 with a probability of 1 and a probability of 2 and stop that. All right, stop at 2. X less than 3 stands for 0, 1, or 2. So how many trials do I have? I've got 14 trials. Probability of a success, I'm told, is 0.077%. Now, when it comes to the X value, I want it to stop adding after it adds the probability of 2. If the calculator behind the scenes is going to take the probability of 0, add it to the probability of 1 defective and the probability of 2. I'm going to stop after I add the probability of 2. Hit paste, hit enter again, 0.930. All right. So that was a lot easier than using PDF 3 times and adding them all together. Same type of problem. I call these the front end. All right. I'm not finding the back end, I'm finding the front end. You have 43% of adults questioned report their health was excellent. The research, which is to study health of people living close to a nuclear power plant, amongst 13 adults. So my end value is 13. All right, only 7 reported their health was excellent. Find the probability when I survey 13 people and randomly selected 7 or fewer are in excellent health. I'm trying to find a probability of 7 or fewer. That translates to X is less than or equal to 7. 7 or fewer. 0, 1, 2, 3, 4, 5, 6, or 7. Well, of course, I'm not going to do PDF 8 times and add those. I'm going to use the binomial cumulative. The binomial cumulative always starts adding probabilities at 0 and it stops adding when I tell it to stop adding. I want it to take the probability of 0, add it with 1, 2, 3, 4, 5, 6, and 7, and then stop. All right, call my calculator up, clear this off. Cumulative. Second function, vars binomial cumulative. Letter B. All right, so how many trials do I have? I've got 13 trials. Probability of someone being in excellent health, 0.43. 0.43. And I want the cumulative to add 0 with 1, with 2, with 3, with 4, with 5, with 6, with 7. Stop adding those probabilities when it gets to 7. Tell it to stop adding at 7. And just hit paste, hit enter again, and there's your answer. A heck of a lot easier than using the formula, obviously. Heck of a lot easier than using PDF 8 times and adding all those. The cumulative does that for us. Pretty nice feature. Let me clear this off, minimize this. All right, so here again now, it changes up. A second way that we utilize the binomial CDF. All right, get 10 true-false questions. To pass the test, student must answer at least 6 questions. At least 6 is 6 or more. At least 6. X is greater than or equal to 6. This has to be correct. At least 6 includes 6 and 7 and 8 and 9 and 10. But notice I'm not finding the front end anymore. All right. You would say, well, I want to use cumulative, but the problem with cumulative, it starts at 0 and stops when we tell it to stop. But what we know is if I'm trying to find a probability of at least 6, 6, 7, 8, 9, 10, I'm trying to, I refer to this as letter A. The complement of letter A is 0, 1, 2, 3, 4, or 5. But I know this. If I'm trying to find this probability, I know that I can take one whole and subtract the probability of all this, and I'll get that answer. These are complements of one another. All right, the probability of all this added with the probability of all that adds up to 1. If I can find this, subtract that from 1, and I'll have what I'm looking for. I refer to this as the back end. When you're using the back end, you've always got to subtract from 1. All right, here again, I could have used PDF 5 times and added them all up. That would take forever. I'm going to use the cumulative, but I got to remember the cumulative starts at 0, so it's not going to flat out work for me. I'm going to take one whole, all right, subtract this, and then I'll have what I'm looking for, what I call the back end. All right, so I start out with going 1 minus, all right, second function, vars menu. Come down to the cumulative. Probability of a true-false question. Now, he doesn't have to tell us this. We know true-false question is 50-50. All right, and I've got, well, here again, I'm looking for this. I want to solve for this and take that answer subtracted from 1. So my trials are 5. All right, and it's a true-false question. Probability of getting it right or wrong is 0.5. In fact, let me take that back. I got 10 trials. 10 trials. Probability of getting it right or wrong is the same 0.5. And I want to stop after I add the probability of 5. But remember what it's doing, it's taking this answer and subtracting it from 1, giving me what I'm looking for, what I call the back end. And there it is, 0.377. Heck of a lot easier than using PDF 5 times. But you gotta be aware, whenever you're asked to find the back end, you're gonna have to take 1 and subtract what I call the front end. I'll give you another problem here. Find a probability that at least 2 girls are born in 7 births. At least 2 means 2 or more. X, probability of X being greater than or equal to 2. 2, 3, 4, 5, 6, and 7. All right. What I'm going to do is solve for that. All right. The complement of what I'm looking for. If I'm calling this letter A, the complement of that is 0 or 1 children of girls. All right, so if I get to this, I'll take this answer, subtract it from 1, and then I'll have what I'm looking for, the back end. All right, so here we go. Let me clear this off. I'm going to start off with 1. I'm going to subtract. Second function, my vars menu. Come down to binomial CDF. All right, and I want to solve for this part right here. How many trials do we have? We've got 7. Probability of a birth is like flipping a coin, still 50-50. All right, and I want to stop. I want the calculator to have the probability of 0 with 1. All right, so I want to stop after I get to 1. Stop after I get to 1. Now, what's going to happen here? It's going to calculate the probability of 0 with 1, and then it's going to subtract that answer from 1, and I'll have what I'm looking for. Since this here and what's in yellow are complements of one of the sums of the probability equal 1. All right, so we hit paste, and then behind the scenes it does its subtraction. Now let's assume that you forgot to subtract 1, and you just did the probability of 7.5 and whatever. You could always subtract 1 later on. Your answer would be some sort of negative number. When you're asked to find the back end, you're always going to have to use cumulative and subtract it from 1. I think I got one more problem here. You get 12 identical components whose functions function independently. Probability of a component failing is 0.2. That's your p-value. Machine will stop working if more than 3. More than 3 translates to x is greater than or equal to 3. Greater than or equal to 3 would be 4, 5, 6, 7, all the way to 12. Well, obviously, you're not going to use PDF and use it 1, 2, 3, 4, 5, 6, 7, 8, 9 times. I'm going to solve for the complement. All right. I'm going to use cumulative. I'm going to find a probability of 0, add it with 1, with 2, and 3. Subtract that answer I get here from 1, and then I'll have what I'm looking for, the back end. Whenever you're asked to find the back end, you got to subtract from 1. All right, there's my calculator. Let me clear this off. And it's 1 minus second function vars. Come down to binomial CDF. How many trials? We got 12 components. Probability of a component failing is 0.2. And I want to stop adding after I get to 3. When I say tell the calculator 3, behind the scenes, he's starting at 0 being defective. He's adding that answer with 1, with 2, with 3. And then obviously I'm taking all that and subtracting it from 1 and getting what I'm looking for. 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3. All right, it's going to stop right there. And go to paste, hit enter, 0.205. All right, I hope that helps clear things up a little bit.